So we're going to be working on notes and examples for 12.5. So you're going to need your notes, and section 12.5 is cones. So you'll want to find the cone section on the notes. Also, if you have made a blank copy of the examples, you'll need to get those out as well. So we're going to be working on section 12.5. So we're going to start with our vocabulary about cones. A cone is similar to a pyramid in that it has a single base opposite a vertex, and it is similar to cylinders in that its base is a circle. So the circular part is the base. Cones, like pyramids, have two different heights that we deal with. So we have the height of the cone. We use the letter H to represent this one. This is the one that is perpendicular between the vertex and the base. So a vertex perpendicular to the center of the circle. This can also be given outside of the cone. They'll draw it in from the vertex down to the base. So this is our height of the cone. Cones also have a slant height. This is the altitude from the vertex to the circumference of the base. So remember, the circumference is the outer edge. So this is the one that we use, the L. So this one goes down the outer edge. So from the vertex to the outer circumference of our base is our slant height, which is the L. We're going to be dealing with right cones. So in a right cone, the height meets its base at the center. So the important thing about this is that we're at the center. So when we draw in our segment that connects the center of the circle to the outer edge, this is our radius of the circle, and our height, our slant height, and our radius create a right triangle that we can use to calculate missing measurements. So we're going to be working with surface area and volume. The cone actually uses the exact same formula as the pyramid, but because our base is always a circle, we have the base area, which is our pi r squared. So this base area is our pi r squared. And then we use half of the perimeter and half of the circumference. So half of 2 pi r ends up just being pi r. And then you have to pay attention to the heights that you use. Remember that the surface area uses the slant height, and our volume formula uses our perpendicular height. So pay attention to which item you need. So we have our height, we have our slant height, and we have our radius. Surface area uses the surface height, which is the slant, and volume uses the inside height, which is our perpendicular height or altitude. So the key to these is, what do we use for pi? Finding the radius. We have our slant height and our height, and we're almost always going to have to use the Pythagorean theorem. So once again, we are going to be looking at this information. So remember on your formulas page that this is that information here in the center. Whether we're dealing with a pyramid or a cone, with pyramids, we always did half a side. With a cone, we do a radius, which is half the distance across the circle. So we're going to work with the radius. So the radius is something that we're going to know. And then we can calculate either of the heights. So we have our height, which is that perpendicular distance. And we have our slant height, which is on the outer surface of our cone. And because we have a right triangle, remember it's leg squared plus leg squared equals hypotenuse squared. So we have our leg that's our height from the vertex to the base. We have our radius, which is the other leg, and then we have our slant height, which is the hypotenuse of our right triangle. So we're going to be calculating surface areas and volumes. Now, one thing about the surface area is, like we did for cylinders, we can apply a little bit of algebra and factor out common information. Both parts of the addition have pi. Both parts of the addition have a radius. And when we factor that out, we have the radius plus the slant height. So our surface area requires the radius and the slant height, and our volume requires the radius and the altitude. So what we're going to do first is we're going to look at our picture and we're going to find our three values. Once we get our values for the radius and our two heights, we can substitute in and calculate. So with this set of problems, notice that we were told to leave your answer in terms of pi. This means that when we go to calculate, we're not going to put any number in for pi. We're going to leave it as the symbol. It means we treat it like a variable. So first things first, I start looking at my information. So from the center of my circular base to the outer edge is a 5. That's the radius. The 13 is on the slanted surface. So this is the L. And the one piece of information that I'm left to calculate is my height. So we're going to do the Pythagorean theorem for the height. So remember that calculation, height squared plus radius squared equals slant height squared. So my unknown height squared plus the radius squared equals the slant height squared. So the 5 is the radius and the 13 is the slant height. So let's calculate. So this is going to be h squared plus 25 equals 169. H squared is going to equal 144. And when we take the square root, our h is 12. So for this particular problem, our height is 12. Okay, now that we know the radius, we know the height, we know the slant height, and we're going to leave it in terms of pi, we're ready to calculate. So our surface area is pi times our radius squared plus pi times our radius times our slant height. When we go to calculate this, we're going to put everything except for the pi into the calculator. So we have a common value of pi, and we're going to calculate everything else. So in the calculator, I'm going to do 5 squared plus, let me move this so you can see it. So 5 squared plus 5 times 13. And we end up with 90 pi. Everything here is measured in meters and area is in square units. So our surface area is 90 pi square meters. The volume is fraction 1/3 times the value of pi times the radius, which is our 5 squared, times our height value. This is the one we calculated with Pythagorean's theorem, so that's the 12. And once again, we're going to calculate. We're going to put in everything except for the pi. So when we get our volume, we're going to have a number in front of pi. So we have our 1/3 times 5 squared times 12. And we end up with 100 pi. Since everything is in meters, volume is cubic meter, so it's 100 pi cubic meters. Okay. Second example. Once again, we're going to leave everything in terms of pi, so no numbers in for pi. We need to know the radius, the slant height, and the height. So this time, when we go to look for the radius only goes halfway across the circle. So that means for this particular problem, this 10 is the diameter. We need to remember that the radius is half of the diameter. So our radius is going to be 5 feet. Once again, we have the measurement along the outer surface. So this is our slant height. So just like the previous problem, we're going to do the Pythagorean theorem for the height. So our height squared plus our radius of 5 squared is going to equal our slant height of 12 squared. So a little bit of calculating. Our height squared plus 25 is going to equal 144. Our height squared, so 144 minus 25 is 119. And when we do the square root, since 119 is not a perfect square, we're simply going to leave this one as the height is the square root of 119. Okay, so now we're ready to calculate surface area and volume. So our surface area is pi times our radius of 5 squared plus pi times our radius of 5 times our slant height of 12. Once again, when we calculate this, we're going to do everything in the calculator but put a number for pi. So this is very similar to what we did in the previous question. So this one is going to be 5 squared plus 5 times 12. To get 85, we keep the pi. Our units are feet and area is in square units. For the volume formula is 1/3 times the area for our circle, which is pi, times our radius value of 5 squared, times our height value, which is the square root of 119. So we're going to calculate our volume. So 1/3 times our 5 squared. Remember, we're not putting anything in terms of pi, we're leaving that. And then we're going to have times our square root of 119. This answer we're going to round to 2 decimal places, so this is going to be 90.91 pi. We have our feet, and volume is in cubic units. When you're leaving it in terms of pi, you don't put anything in your calculator for the pi value. You do all of the other number calculations and keep pi as part of your answer. So the next set of problems has a slight difference to our information. This time we're going to use 3.14 for pi, and we're going to round to 2 decimal places. So it's the same basic process, only this time we actually have a value to put in for pi. So we have our pi, we have our radius value, and then we have our heights. We have the perpendicular height for the volume, and we have the slant height for the surface area. So in each problem, look for which information they tell you. So in problem 3, we have the perpendicular from vertex to the center of the circle. So this is our height. We have the measurement from the center of the circle out to the circumference. So this is our radius. And that means for this problem, we need to calculate the slant height. So we're going to do the Pythagorean theorem. For the slant height. So it's always going to be the height value squared plus the radius value squared to equal the slant height squared. So 12 squared plus 4 squared, 12 squared plus 4 squared is 160. So 160 for the slant height squared. 160 is not a perfect square, so I'm going to leave that value as the square root of 160. Now for the surface area formula, we're going to put in 3.14 for pi. Our radius value is 4. It gets squared. Then we do plus our 3.14 for pi times our radius value of 4 times our slant height value of the square root of 160. So this is what we're going to calculate. 3.14 times 4 squared. 3.14 times 4 squared plus 3.14 times 4 times the square root of 160. So this is 209. 2 decimal places is 1, 1. Everything here is in centimeters and areas are square units. And then for the volume, 1/3 times the value of pi times the value of the radius, which is 4 squared, times our perpendicular height of 12. And we calculate. 1/3 times 3.14 times 4 squared times 12, rounded to 2 decimal places, is 200.96, Everything is in centimeters and volume is in cubic units. So each time you're working with cones, we need to know what to use for pi, what to use for the radius, and surface area uses slant height, volume uses height. So in problem 4, we have the measurement from the center of the circle to the outer edge, so our radius is 5. We have a measurement on the slanted portion of our cone, so that's our slant height. And in order to calculate the volume, we need the perpendicular height. So we're going to have to use the Pythagorean theorem. So it is our height squared plus the radius squared in order to equal the slant height squared. So when we calculate, this is going to be height squared plus 25 equals 64. Height squared is going to equal 64 minus 25 to get 39. Since 39 is not a perfect square, we're going to leave it underneath the square root. So we have radius, we have slant height, we have height, and we have the value of pi. So we're ready to substitute into the volume and surface area formulas. So let's start with our surface area formula. Our surface area formula, pi r squared, so 3.14 times the radius value of 5 squared. And then we add pi RL. So we're going to add 3.14 times the radius value of 5 times the slant height of 8. And now we go to the calculator. Pi times the radius squared plus pi times the radius times the slant height. I left out a number. Let's see if I can insert a 4. There we go. So this is a surface area of 204.1, and everything in this problem is centimeters and area is square units. Now for the volume. So our volume formula over here, 1/3 pi r squared h. So it always has the 1/3 times, this time 3.14 for pi, times our radius value of 5 squared, times our height value of the square root of 39. And we calculate. 1/3 times pi times the radius squared times our height, which is the square root of 39. And this is 163, rounded to 2 decimal places is 4.1. The units are centimeters and volume is in cubic units. To make sure you can identify the radius, the slant height, and the height, pretty much every one of these problems is going to require the Pythagorean theorem to find one of the two heights. So height squared plus radius squared equals slant height squared. And the next question, we're going to use the volume formula to find a missing measurement. So we have the volume formula of 1/3 pi r squared h. They're going to tell us the volume, and we have to find one of the two missing values. So we start out the same way that we've been. So we start looking at our formula. So we need the radius, and in this particular problem, our radius is 6. We need the height. And in this particular problem, our height is what we're going to be calculating. Our value of pi is 3.14, and we have the volume to fill into the formula. So let's start substituting in. The volume, 182. This is equal to, we fill in 1/3 times, then we do our pi value, 3.14 times. Now we're going to do the radius value. So our radius is 6. This value gets squared times, and now we're going to use the height value, and our height is the x. Everything is in, so the next step is to simplify. So we're going to simplify our information on the right side. So we have 1/3 times 3.14 times 6 squared. So this is 37.68 times x. To get rid of multiplication, we're going to divide by that 37.68. So in the calculator, we're going to take 182 and divide it by the 37.68. We're rounding to 2 decimal places, so 4.83. Everything here is inches. Our radius is in inches. Our volume is in cubic inches. That means our height is in inches. So this is our value of x. Our value of x is 4.83 inches. So when you're working through these problems, make sure that you're using your formulas. So in your notes page, make sure that you're paying attention to the cone formula, and make sure that you pay attention to this section in the notes in how to calculate for the missing height value. This works for both pyramids and cones. The perpendicular height plus the radius, or height squared plus the radius squared, equals the slant height squared. So use your notes carefully. So make sure that you're using